array quadruplet. They are asking me to find 4 elements that add up to a given sum. I know a solution that works for 2 elements in a sorted array. I can start with the first element and the last element, and then move them inwards to find a sum. Now I'll have to extend. I think extending that to 4 elements might be a good way to approach this problem. So I can readily extend it for 3 elements. Let's say I first sort the array. I take the first element of the array in the outer loop. In the inner loop, I have 2 pointers that find something that sums up to the remaining elements. So for instance, I'll just take an example here.
That's the example given in the question, yeah.
Yeah, that's the given example. First thing I'm going to do is sort it. Five, 7, 9. Next thing what I'm saying is, let's say I'll take 0 on the remaining array. This just solves it for 3 elements. Suppose the target is 20. So 20 minus 0 is still 20. I try to find 2 elements that add up to 20 in the remaining array. So this will solve if the question was just 3 elements from the array, but we are having to find 4 elements. So suppose I do this. I have 2 outer loops. So and then the target is 20, and in the array I'll have to find 19. So 20 minus 0 minus 1 is 19. So I'll have to find 19 in the array 2 to 9. So, but this will have a complexity of n squared. It will be a n cube.
So let's say n cube is good enough for this problem, actually.
Okay.
As long as it's not worse than O(n) cube, it's a good solution.
Okay. So in that case, is it okay if I start coding this approach?
So if I understand correctly, your approach is having an outer loop and then having a loop inside that, and you have 2 loops, and what do you exactly do inside the second loop?
Okay.
I mean, I don't really.
The innermost loop is something like this.
Yeah.
So let's say this is the innermost loop.
You already picked 0 and 1, so now you added them, and you're looking for 20 minus 0 minus 1 in a third loop, right?
Yeah.
Yeah, that makes sense.
So in the innermost loop, I have 1 pointer here.
Okay.
And the other pointer here. So in this case, 19 is already greater than the sum of 2 and 9.
Okay.
So I will not be able to find an answer here.
So you took the approach with the 2-sum problem, and you're just implementing it after you go inside two loops.
Yeah.
That makes sense because you reduce the problem to two-sum problem, basically.
Yeah.
That makes a lot of sense to me. So why don't you start coding?
Okay.
And you said, of course, you're going to sort the array before, yeah. Mm-hmm.
Okay. Actually, I'll not call a different method. I'll just write it here.
Oh, you're going to write a separate function? Oh,
No, I thought I'll write it in a separate function, but I think it's easier to write it.
I guess so, yeah. And is K the first pointer and L the last pointer?
Yeah, K is the first pointer. In this case, it will be pointing to 2.
And L will be pointing to 9. Okay.
Yeah. Okay, let me think about it. Okay.
So what is your
Yeah, I'm just thinking about the condition that I need.
so you're going to access the kth element and the lth element of the array.
Yeah.
Yeah, that's a good idea to do the sum before. Mm-hmm.
The sum is smaller. No, while the sum is greater than equal to this, then I can find an answer. If it's less, it's greater than. Okay, let me take an example. Let's suppose I want to. In this, I want to find. 11. It'll break.
Instead of saying break, maybe you can just return I, J, K, and L because you already found the solution.
Yeah.
Mm-hmm.
And my video recording start.
I'm sorry, what?
It looks like maybe recording stopped and starting it again.
Oh. So,
suppose it's greater. If it's greater, then there is no way I'm going to find a solution for that. No, if it's should be less than equal to. If it's lesser,
so you have a K and L pointers, right? At some point, you're gonna
yeah.
bring them closer.
Yeah. I'm confusing myself here. Let me just write down. Like, suppose in this case, I have to find out 12, say 16. So I have to increase it. So if I have to increase it, I think that's not what I should do. I should just do
Yes.
for like K.
Because when the while loop is gonna stop when the pointers actually meet.
Yeah. So that's the condition.
I think that's a better while loop. Yes. Okay. So.
I'll have to move this inside.
Mm-hmm. Yeah, that makes sense.
Okay. Some less than.
Mm-hmm.
Okay, I'm moving the first pointer.
You're gonna increment the K pointer.
Okay, this is what I need to do.
Yeah, actually, that looks perfect.
Let me just verify it once for this given question, and then let's see.
Sure.
I'll run the test cases.
Yeah, that's a good idea.
Okay. 0. Okay. Plus 1. Okay. J plus 1. Okay. While K less than L. Some. Okay. This should have a.
Yeah, can you think of a case where the function well, what if an array with less than 4 elements
Yeah.
or an empty array? Yeah. We can just, yeah, we know that there's not going to be a solution. Null or an empty array or whatever. I mean, doesn't really matter. We'll see what the test cases expect, so we can see that after.
It's such a quad. Okay. Sorry, it's actually given in the input. It's expecting a
empty array. Okay.
Yeah.
All right. Let's do that then. Yeah. Mm-hmm. Okay, so
Okay.
so are you returning the indices, or are you returning the elements? Because it looks like
Okay. They want the elements.
it's expecting the elements themselves,
Yeah.
but you're returning, the indices. So and now it's perfect. Before we move on, can you think of a little optimization you can do? Like if you look at this line, you're calculating the sum, but I plus j doesn't really change once you're inside the second loop. Yeah. So maybe you can
That's
calculate that before, and you're really looking for sum minus RA plus RJ, right? Because this part should add up to whatever the sum you're looking for is. So maybe you can even calculate the difference between sum and the RI plus RJ. So
fair enough. Like I think more than that, not extracting it out each time will save.
array I, array j, yeah. Yeah, I mean, you can do that too, but I guess like you're still adding them, but this sum doesn't change as well. And
Yeah. Awesome.
yeah. Mm-hmm. That's a little bit more optimal. Oh, and if you're done, we're gonna go over the time complexity and space complexity of your solution.
Yeah. I think I'm done. I'll let you know. I mean, I'll discuss the time complexity first.
Okay.
We are first sorting the array.
Yes.
So that will be an n log n.
N log n complexity. Yes.
And then anyway, it's overwhelmed by the for loops that we have following. So we have two for loops and then a while loop. So they are nested and
in the worst case, what is that while loop gonna do?
it's going to be a linear while loop. So yeah, this entire code will be a n cube algorithm.
It's gonna be n cube plus the sorting, n log n plus n cube. So n being the, we can just say n cube, but n being the number of elements in the array. Just to clarify that. I mean, it was obvious. We're not using what?
Okay. Other than integers, we are not using any real.
I think this is the most optimal solution that is possible.
Okay.
As far as I
was actually thinking of something if I can do some sort of binary search or something, but I couldn't think of anything that will work.
Yeah, I mean, technically, you're doing something that can be considered kind of binary search because you're not basically going over the entire array after the first two loops. But this is, I think, the most optimal solution that is possible because that's also the pseudocode solution that I'm given. So,
okay.
So I think you did a great job. And space complexity.
Yeah, in terms of space complexity, we are just having some constant space.
Yeah, just constant space. So we can say O1. We're not actually storing anything. So yeah, space complexity is O1, yeah. Time is O n log n. N cubed. Okay, sounds perfect. I think we're done. So do you want to swap roles now?
Yeah, sure.
Great. All right. Let's see. Decrypt message. Infamous gang of cyber criminals names the Grey Cyber Mob. Let me read it actually silently. Mm-hmm. So we have a link to the ASCII Characters table. Okay.
I just want to mention that you're given the encrypted word and then you'll have to decrypt it.
I'm sorry.
The algorithm that they describe in the question is actually to encrypt a word. From crime, it becomes D, not Q.
Yeah, I mean, we're assuming it's you mean, are we writing a decrypt function or an encrypt function?
Yeah, we are writing a decrypt function.
Okay, so I see.
Yeah, that sometimes people miss it.
So let me copy over the example cases. So actually, like, this should result in crime. And this should result in encyclopedia. Okay, so let's see what is the encryption method. Add 1 to the first letter, and then for every letter from the second one to the last one, add the value of the previous letter. Subtract 26 from every letter until it is in the range of lowercase a and z. in ASCII. Okay. Convert the values back to letters. Yeah, so first of all, I think I'm going to need a function to take the letters and turn into ASCII values, right?
Yeah, I think that'll be useful.
Yeah, so let's see. In JavaScript, I will have to look up the function. So basically it says you can search the internet for the appropriate method.
Yeah, sure. I can search it for you if on the side by side.
Yeah, you can. Yeah, just the JavaScript method for.
You can also search it. I'm okay with that.
So let's see. So we found this.
Yeah, to convert it from string to say, sorry.
Oh, I see. So yeah. That's what I. And also, this. So it's going to return A. It's going to return 65. Right. Okay. Wait, why? Why is this returning? Oh, because this is yeah, it's lowercase a. Okay, I see. I mean, we can just say this, and I'm assuming this is like. Okay, this returns 65.
No. I guess I think whatever you had was different. Sorry. So the first one is to convert from string to integer, and the one that you had was to convert it back from something like that, right?
Okay. Let's run these and see. All right.
I just want to confirm that is this your preferred language of choice, or do you want to change the language to something else?
No, I picked JavaScript.
Okay.
Yeah, it seems to be working.
Yes, okay. Yeah.
I see. Okay, so let me have functions so I can actually remember these. Let's say letter to code, and I want to have code to letter. And This one is gonna give me the code for the letter. And now I'm gonna do, if I return this, this will give me the letter for a code. So now what I'm thinking is I will have a function that handles a single letter, because the encryption algorithm is not even connected. Like, it doesn't matter how many letters they are, and the letters don't really interact. So every letter can be decrypted individually.
That's not really true.
Is that not really true? Okay, let me read it again then. Oh, the first letter is treated differently.
In fact, first letter is the only letter you can decrypt without knowing other letters.
Okay. So first letter will be decrypted separately, and then for every letter from the second one to the last one. Oh, right, I see. Okay, I misread it the first time. I need the code from the previous letter so that I can, add the value of the previous letter. So I'm thinking then I can just turn it into an array of numbers. I can take the word and turn it into an array of numbers and then process it. And then...
Yeah, that might help you.
That might work?
Yeah, that I think will keep your code clean.
And after that, I can decrypt every number. And then I can just, in the end, I know how to turn it back into a word, so I can just do that by using my code to letter function. Yeah. So let me turn word into number array. So my word is a string, and I can iterate over a string by using this. And for every letter, I want to use letter decode. Actually, let me have a regular loop and let me see. Okay, so let me initialize an array, and then I will figure out how to optimize it.
Mm-hmm.
So I can just say empty array, and I can push this into my array. And when I'm done, array will be the an array of numbers, and each number representing the letter. And now I can work with that. So now what I can do is I can handle the first one. That will be array 0th element, and that's gonna be, we're gonna add 1 to that, and
in fact, you're going to -1 actually.
what do you mean?
You're going to get D not Q, and you have to generate crime, right? The algorithm that they have described
is the encryption algorithm, not the decryption. You're right.
Yeah.
But obviously I need to modify. Yeah, so I'm going to subtract 1 from the first element in the array. And then that's all I have to do for the first element. And then for the rest, I want to have a loop. Well, I'm going to start from the first one now because I already did the first element. So what I want to do here is I'm going to need a way to keep track of the previous code. Let's call it previous. And initially, it is, well, just say I minus 1. So initially it's going to start with 0. And it's in the encryption algorithm. It's adding the value of the previous letter. So instead, I should do the opposite of that.
Yeah. We can maybe take a small example and then just try, just for don't think of the entire word. Just think of like DN.
Like, do you think I should like say ABC?
No, let's take whatever they have given, but just instead of considering the entire full word, just consider this as the input. DN.
DN?
Go to CR.
Yeah. So we subtracted 1 from D, we get C, because C was encrypted by adding 1 to its value. And for N, how was
the value is 110. Okay.
110?
It was 100 and 110.
Okay.
Now you have subtracted 1. So this is what it is when it starts the loop.
Okay. So now,
so from N you'll have to get R.
So how do I get to R from N? I have 110 here. So like 110. What is the value for? Let's see.
R is actually 114.
Yeah. So we're trying to get to 114. And what we do is add the previous, we subtract the value of the previous letter, but that will be 100 because we already modified D, but we need the value before modifying it. So what I'm thinking, what we can do is either we're going to stay behind in the loop, or we're just going to have the previous elements outside the loop. Oh. And we can update the previous element before actually touching it.
I think you probably want to do it last in the loop.
Yeah, no, you're right. Oh. So let's see.
That also will not work because you would have already calculated.
Yeah, that's why I was doing it the first.
You should do, yeah, you should do it within the loop, but before you change the value. It's like you do everything in a temp and then.
I see. Yeah, that's a good approach. Okay. So I guess I can have a temporary variable. Eventually, I will set this to temp, and I'll modify array I by subtracting array I minus the previous element, which is actually my. I already had a variable for that. It's previous. And then I can update my previous. But yeah, no, this should work.
This will not work as it is because when you subtract 110, 99 from 110, it will not be 114.
So if I'm subtracting 104,
you're subtracting 99 from 100.
It's not going to be 99 though, because I.
Okay, yeah, you're going to subtract 100 from 110.
This is going to subtract 100 from 110. That's right. So what was the value for C? It's 99. So we're trying to get to 9904. Yeah, so how do we get to 104 from 110? Because, let's see. Add value of the previous letter and subtract 26 until it's in the range of letters, but it's already in the range of letters A to Z, right?
No. So after this step, we have converted it to 99 and 10, right?
Yes.
No, we'd have to do something to convert it to 99, 114.
So 99 is in the range, but 10 is not. So I will keep adding 26 until it gets in the range. And the range starts from 97 to 122, according to my table. So what I want to do is basically, I will keep adding 26. So this was 10. So 10 plus 26 is going to be 36. 36 plus 26. It's going to be 62. Still not in the range. And I can, when I finally add 26, this is going to be 88. Still not in the range. So now I add 88 to 26. This is going to be 114. which is what I was looking for. So I think this loop as it is will handle the first, let's say first iteration, but then I can, again, this is not exactly optimized, but once I do this for the entire array, I can just come back for the elements that are not in the range and I can handle them.
Okay.
So that's what I'm thinking now. So by the time I'm here after the loop, I'm gonna, I mean, I can do it in the same loop actually, I guess. All I have to do is here I can just check I can check if array I is in the range. So that would be, we said the range was 97 to 122. Check if in range. So what I'm going to do is I'm going to check if it's greater than 97 or equal to. As well as if it's less than or equal to 122. 122. I mean, or I can just say wait, no, okay. Just want to have negation here.
So what is the condition that you want? You want to see if it's an invalid...
If I want to see if it's not in the range.
Okay.
I guess it should be a while loop because I'm going to keep going on. So, I mean, do you think something's wrong with the approach?
Yeah, I would want...
This is what I was thinking.
Yeah.
While it's not in the range.
Yeah. There is a small edge case that you are missing.
There's a small edge case. Okay. The small edge case being, even when I get in the range, I will know. Once I get in the range, it should stop. What am I missing here? You're specifically talking about just this part, right?
If you look, it's not limited to that, actually. There is a difference between your previous approach of like first having an intermediate array and then processing all elements and this. So there is some, you are missing something, no. But suppose your original approach was to pass through the array again and then calculate, right?
Yes.
Yeah, that would have worked, but this will not work.
Interesting. What is different about this? I can't see it. Array I is equal to array 1 minus previous. But I'm basically doing the same thing just before I finish my first loop. So can you just like give me a hint about this? Because I can't really see.
You're not doing it for the first element.
What? Oh.
You will not?
Yeah. I see. Right. So that's annoying. So I guess I will. Well, let's just. I guess it wasn't a good idea to handle this outside the loop, I guess. Or like eventually I'm gonna have like some kind of separate code, so might as well just have this specially handled. So
yeah, you probably would have created a function or something for it.
That would have been the better approach.
What I'm saying is like this while loop is essentially a function, right?
Yeah.
Meaning you're putting it in two places.
You're right. So should I like make a function for that now?
That's fine. Let's see if this works as it is. Then we can come back and clean up the code.
Okay. So now I'm handling the first element specifically, and then I'm just like doing it for the rest of the loop. So like let's return the array, but obviously I just want to run my code to letter function on every element and return that.
Will it automatically join the individual?
This should run the code to letter function on every element in the array.
Okay. What I'm asking is like, will it return an array of characters or will it return a string?
Oh, it'll return an array of characters. Yeah. I just wanted to see if it works.
Yeah. Okay.
Just wanted to test. And I just want to write a test case too. So let's just say decrypt, not crime. Previous is not defined.
Okay. Don't print anything?
Right, I guess
Or you have to print it?
we want to see the output. So
Yeah.
it did return crime, but obviously I want to join this to make it a string like this.
Yeah.
So let's see. Let's actually get rid of this repetition. But I mean, before that, I'm just thinking, like, can I optimize this further?
You can create the string as it is without having another map in the return if you want.
I'm sorry, I didn't hear.
Instead of having a separate
Separate array? I can just do it in place?
no, what I'm saying is like in line 28 you are again iterating through the array, but you can directly construct the string. But I'm fine with that. It doesn't increase the complexity in it still has linear complexity. It's fine.
Oh, so I'm using extra space here. Is that what you're saying?
Yeah, I'm just saying like right now in line 28 there is a map function.
Yeah,
Yeah, it's iterating through the array one more time.
it does. So I can.
Yeah, but it's fine.
I guess you're saying I can handle that within the loop.
Yeah, if you want to, but I'm fine with this. This is cleaner to read.
I think, yeah, actually it is cleaner to read, and it doesn't make a huge difference actually, because it's
Yeah.
not an exponential effect. Yeah, okay.
But yeah, as far as the while loop itself is concerned, I
Right.
think it's repetition. So that's something that
Let's just fix this, right? Okay. So let me get rid of these. Yes, bring into range. And we're going to have a code here. Obviously, code will be implemented eventually. Maybe return. Wait. So what I can do now is zero is equal to similarly here. Range array. Yeah. So let's run the tests actually, just to see if it passes the test cases as well. Is this creating the problem?
okay. It's failing one case. Incompressible.
Let me run it again because maybe this is interfering with it. I don't really think so, but the test did not run because the previous test had failed.
Drug trafficking. Okay, what's the difference between the two?
Oh, it's an empty string. Maybe we should handle the empty string separately. So bird is equal to an empty string. Just want to return an empty string. Yeah, that makes sense. Okay. So yeah. I guess this looks good. Oh, should we go over the time complexity?
Yeah, sure, but I don't think there's much to it.
Yeah, I mean, because basically what we do is we go over the array once, and then, like you said, we go over the array for the second time. So n being the number of elements, 2n, I guess. So it's linear complexity. Yeah. And space-wise, we're actually generating extra space here. We can actually do this in place, but well, I guess we're running out of time, but what we could do is I think we could do this in place as we go over the array, right? Instead of initializing a new. So like space-wise, on space, we're using an array that is equal to the length of the string.
Yeah.
Okay.